Dear students, in the last lesson we have learned how to work with basic root operations in the MongoDB database. We learned how to insert data through the insert command, how to withdraw data using the find command, which has plenty of options, but we have gone through only the most elementary ones, and then how to change data using the update command. The last command that was dealt with was the remove command, using which we have deleted all men from the database. Now I'm going to show you how to work with indexes in MongoDB, since indexing is quite an important part of working with databases. So how does it work? All data in all collections are saved within some documents. When we start searching for them and there is no index, the command that we are working with has to search through each document individually. If we create an index above an attribute that is frequently used for searching, it means that a separate file gets created containing only the ID of the document and the value of the index. MongoDB uses a balanced index tree, also called a B-tree index. It works in such a way that values are always stored so that they can be found as easily as possible based on their selectivity. It means that the data should be as diverse as possible. Taking this into account, it is quite useless to try to index, for example, the gender column, where there are usually 2, 3 values at maximum. The third option would usually be null, but otherwise they would either be male or female. Such index wouldn't be of much help. It would divide the database into 2 parts only. Null values are not indexed by default. To sum it up, we should only index such attributes that have a high selectivity rate. When we take a look at this search example, we will find one user called Tomáš who is 30 years old. What is important about it is that the selected search attribute is the name. If we add the explain command along with an execution stats option after the command for selection, we are also going to receive information about the way the database searches for the data. It is important that there is the condition that we are searching for the name value that equals Tomáš. Another important thing is this data. In our case, the execution time equals 0 because the database is still tiny. There are no entries, and there is basically no reason to index a database like this one. If we had a database with thousands of entries though, the information about the execution time would have been in hundreds of milliseconds for sure. We'll first take a look at what indexes are already there. If there was even a single one, the database would have already used it. If we take a look, however, we can see that there really is no index yet. The only thing that's there is the compulsory ID index. Let us create an index for name. Index creation is rather easy. We will just note the attribute that we'd like to index, where the value of 1 means that it's a standard classification, while if we wanted to sort the index in descending order, for example, we will enter the option of -1. If we take a look at the indexes now, we can see that the name index is already there, along with the compulsory ID one. If we go back to the execution plan, we will be able to see that it uses the name index. At the same time, we can see that the values have changed. They haven't changed too much, to be honest, but we can see that from the initial 3 lines that needed processing, only 1 is left. It would also be good to mention that the more indexes we use, the more our operations slow down. Operations like insert, update or delete. It is so because if I need to edit the data somehow, I cannot just change the data files, but also the indexes. The more indexes I have, the longer the operation will take. And since databases or collections that have less than hundreds of entries are not necessary to index, I can just drop the index the same way as I had created it. And when I take a look again, I will learn that the index was dropped successfully. Apart from the compulsory ID index, there is none left.